Welcome everybody out to the video in the Takt Production System series that's going to cover the path of critical flow. So really in construction schedules, and I know there's some debate about this, the real way to measure a project is through what's called a path of critical flow. Critical paths themselves that run through activities are really only so useful. It only has the ability to measure one thing, but a path of critical flow can measure multiple things and really help you to identify if you have a correct overall total project duration. And so this is based on critical chain theory, which has been shown to be over 40% more effective than the critical path method. And what it is it's a system, obviously in the Takt production system, where we link together these phases, but we do it with some very specific details. So every phase has a sequence. This sequence can be verified and validated with production rates and with the sequence of work and through pull planning. You have the line of balance of every phase, which essentially tells you the speed that the train is going. And because we have a mathematical relationship, we are able to track what is called the realized flow potential. So we know the ranges that you have to be in for your train speed in order for us to be delivering a really good product for our customer. At the end of phases, you have buffers like we've already talked about, and then you have interconnections, you have interdependence ties. Linking these together is what creates your path of critical flow. Now, why is this different than a critical path? Because it takes into consideration trade flow, and it also takes into consideration buffers, both of which you must have if you're going to be successful. So this is an expanded image of what this looks like. So again, if you have a sequence in a phase, you can analyze that for accuracy. If you have a line of balance, you can analyze that that is within the proper ranges. Every phase should have its own buffers, its own interdependence ties, and then the sequence will build throughout to where you end up at the project buffer at the end, and you have what's called a critical flow path, or a path of critical flow. And if you also have your materials tied with buffers as well, you will have a stable system. Now, if you have a delay, and the delay information is listed in the book, if you have a delay, you will be able to experience that delay in the schedule and then trace your sequences, your interdependence ties, and your line of balance and any remaining buffers all the way to the end, so that you can verify or justify, hey, yes, this is a legitimate delay. If I'm an owner and I'm talking to my contractor, I can literally look at the delay, validate the delay, look at the sequences, validate the sequence, look at the interdependence ties, validate the ties, and look at any of the speeds that our trains are going, or the line of balance, or the realized flow potential percentage, and say, yes, that's within the proper ranges. So every single part of this is verifiable, so that you know if your contractor, like I said, if I'm an owner, you know your contractor has a legitimate claim to a delay, because delays do not just happen on a critical path. They happen as a part of the phase as a complex system, and that will show up very well inside the Takt production system itself. So let's talk about CPM for just a minute. So CPM, I believe the proper place for this is that CPM monitors, if you have to have it because of a contractual requirement, that CPM will monitor the overall phases of the project and stay at a level 2 or level 3 high level schedule. Here's what I want to see, that if you have a building, each one of those phases is governed by Takt and put into the Takt production system, and that then the CPM structure simply summarizes those overall phases themselves. So this is what it would look like. The superintendent is running the macro and the norm level Takt plan. The superintendent and scheduler, where they interface with the owners, will have that CPM summary if they want it. Most owners that I work with would rather see the Takt plan. And then the superintendents and the foreman will be using the norm level Takt plans with the look ahead plans, weekly work plans, and day plans to run the project. So if you have a macro level TAC plan, and that's what the norm level TAC plan looks like for that phase in the same example we've been using, the phase summary, the way that would look in a CPM format is like this. You would simply summarize the overall phases. You can also do a sequence summary where the sequences inside those phases are summarized. And you can also do an exact replica, which I personally do not recommend because that's a lot of duplicate work and it's quite unnecessary. We want the TAC plan to be very nimble and a flexible system. And once you've locked it into CPM at this level of detail, it's very hard to change. So the purpose of this is that we can have a plan early on in construction in the TAC production system and in CPM so that we can do most of our planning early on. And so every project will have, like, let's say, for instance, in this example, 8 problems. Well, you can either do a little bit of pre-con and find your problems in the field, which will extend your project, or you can do the right amount of pre-construction effort and find your problems early on. In order for you to do that, you are going to have to really get good or really get used to using these macro and norm level TAC plans and be able to do a fresh eyes meeting or a risk review with those schedules so that you can find your problems and prevent them before you go into construction. And then, like I said, if you have to summarize in CPM from a contractual standpoint, go ahead and do it. But the idea is in the conceptual design phase, we need to organize the pre-con team, confirm the overall duration with the macro level TAC plan, verify your general conditions and your general requirements, and confirm your overall budget. We also need to update that macro level TAC plan, do an early utility review, a geotech review, get BIM started, develop a plan for long lead procurement, start using your procurement log, map out your permits, and develop your team positions in your pre-con effort. You are going to use your macro level TAC plan specifically in these phases in design and in pre-construction. Then in the design development phase, you will develop your buyout log, bring in your design assist partners, really get your builders involved. Who's going to build this building? They need to be developing the norm level, at least for the first 90 days, the norm level TAC plan, modifying the macro level TAC plan, doing constructability reviews, refining that planning so that we can do that risk review before we start the finalization of our construction documents, our construction drawings. Then, and hopefully you have at least the first 90 days in the norm level, you're going to finalize your TAC plan, your zone maps, your logistics plan, your roadblock tracker, your risk and opportunity register, and your procurement log. You're going to start preparing for safety quality the first 90 days, start team building, set up the office and the trailer, and sit down and tear apart that plan and make sure that it is 100% correct. So everything that we have shown you in this book from an example standpoint is only as good as your ability to review it with other team members before you go to construction. Tear it apart, find the problems, fix the problems. There's no such thing as one person creating a schedule by themselves and having it work. You can create that schedule, but you must then enable the team to own it and review it as a team. Then you can finalize your costs and establish your GMP. So we work in construction with a path of critical flow, meaning that once you now have your phases tied together and you have the correct overall total project duration, you are now ready to go build that project, and now you have a plan that is approved. I hope you've enjoyed this quick video about the critical flow paths to critical flow. On we go.